Hi students, this is Miss Young. This video is to help you with our Chapter 6 Practice 2 assignment. So there are 20 questions in the assignment, which I know is a lot. I am going to go over every single type of problem. You will have different numbers, but this way if you're stuck, you can skip around. You do not have to watch this whole video. I know this video is going to get long. A lot of these questions are review. All right, so we are going to be multiplying some decimal numbers. The way we've learned to do this in class is to multiply these without the decimals, and then we move the decimal over. So I will review how to do that. So what I'm going to do first is 693 times 681. So I just pretended those decimals were not a part of it. Then you may know a different way of multiplying. In this class, we've been using a generic rectangle because it helps us connect different concepts. So that is how I'm going to do it. For 693, I'm going to write it as 690 and 3. For 681, I'm going to write it as 680 and 1. So I have a 3 by 3 rectangle. Notice if I was using or actually finding the area and wanted it to scale, I would need to make this side longer, but it's okay because it's a generic rectangle. So here in this top corner, we have 600 times 600. I do 6 times 6, I get 36, and we need 4 zeros on that. So I put my comma right here. And I'm using a different drawing tool so I can write directly on the screen, so it's a little messier than usual. 600 times 80, I do 6 times 8, I get 48. And I need to tack on 3 zeros. 600 times 1, that one's a little easier. It's just 600. 600 times 90, 6 times 9 is 54. I have my 3 zeros. 90 times 80, I have 9 times 8 is 72. Then 2 zeros. 90 times 1 is 90. 3 times 600, I do 3 times 6, I get 18. 3 times 8, I get 24. 3 times 1. Oh, that's a lot of numbers. Okay, now we get to add them all up. I'm just going to stack up the numbers. One trick you can do, or maybe not a trick, but one strategy is to write these as you go on the sides. You don't have to do this all at the end. I'm doing this. I wish I had my other pen tool because it's really messy. Okay. So I'm adding all these numbers. In the ones place, I have a 3. The tens place, I have 9 plus 4. That gets me 13. I carry the 1. 1 plus 8 is 9. 10, 11, 12, 13. 13 plus 6 is 19. Carry this one. 1 plus 4 is 5. Plus this one is 6. Plus 8 is 14. Plus the 7 is 21. Carry the 2. 2 plus 6 is 8. Plus 5 is 13. Plus the 4 is 17. Carry the 1. I get 4 here. Okay, so that is our answer to 693 times 681. But the last thing you need to do is count how many numbers are past the decimal in the question. So I have this 9, this 3, this 8, and this 1. There are 3 digits past the decimal, so I go 4 digits past the decimal. I go 1, 2, 3, 4. So I'm going to type these numbers, but my decimal is going to be after the 47. Notice I accidentally typed a comma. Make sure it's a decimal. Okay, we got that question right. It's a lot of steps. Be careful with it. Let's go on to the next one. So I'm going to clear here. Okay, this one's a little less hard because if we're getting rid of the decimals and multiplying it, we can just do 37 and 46. The zeros in the front don't change what numbers we're multiplying for this step. So we are going to do 46 times 37. And again, I'm going to make a generic rectangle, but this one's a lot smaller because it's a 2 by 2. So I have 40 and 6, 30 and 7. Here I do 40 times 30. 4 times 3 is 12. Here I do 30 times 6. Here I do 40 times 7. Here I do 6 times 7. Then I need to add these all up. Notice I forgot the comma. I will not take off points for that, but it helps us stay organized. 8 and 8 is 16. The 4 is 20. 2 and 2 is 4. 5, 6, 7. Okay, so we have this number. Then we need to count how many numbers are past the decimal. Now here is a key point. When you're counting the numbers past the decimal, you do need to count these zeros that are in front of the numbers because they do affect the value of the number. So we have 1, 2, 3, 4, 5, 6, 7 numbers past the decimal. So we have to be really careful. So I go 1, 2, 3, 4, 5, 6, 7. Okay, I need a zero in my ones place. We have empty spots in the tenths, hundredths, and thousandths place, so I have to put zeros there too. Okay, so if I type this in, I get 0.00011702. And we got that one right. These ones I hold my breath when I hit it because there's so many little spots for error. That's why I give you as many redos as you need. I know it does change the numbers after 3 tries. Okay, so let's clear our drawings and go on to question 3. And this one is the last decimal number multiplying. So we're going to do 5.8 or 5 and 8 tenths times 9 and 48 hundredths. So I need my drawing tool. Again, we multiply with no decimals. Just ignore the decimals. Draw a generic rectangle. This time we need a 3 by 2 because this number has 2 digits. And this number, the second number, has 3 digits. And I almost messed up here. Hang on. Sorry about that. So we have 940. Okay, here we go. 900 times 50. 9 times 5 is 45. And then we add on those 3 zeros. 8 times 9 is 72. Throw on 2 zeros. 4 times 5 is 20. We need those 2 zeros from here and here. 40 times 8. 4 times 8 is 32. Throw on a 0. 8 times 5 is 40. Throw on a 0. 8 times 8 is 64. So we need to add up those 6 numbers. And sometimes in my answer, I purposely don't put the comma because I know I'm going to be moving decimals around and it kind of gets in the way. Be careful copying these down. It's so easy to make little mistakes here, but it's good practice to do these. In the ones digits, I have 4. Okay, 2 plus 6 is 8. 4 plus 2 plus 3, going to be 5 plus 9. 5 plus 2 is 7, plus another 7 is 14, carry the 1. Okay, now normally I would put a comma right here, but we need to move the decimal 1, 2, 3 places. So I'm just going to go 1, 2, 3. So here I get 54.984 or 984 thousandths. Good, we got that one right too. Write these out on paper so that if you make a mistake, you can ask me and I can check it for you, or you can catch your own mistake. Go on. Okay, here we have a multiplying improper or mixed numbers, but it helps to change them to improper fractions. Otherwise, you need to make a generic rectangle, and that ends up being a lot more steps. So I'm going to copy down the question over here. I have 2 1/5 times 1 1/2. We first convert them to improper fractions. So I do 2 times 5, and then I add on the 1. So 2 times 5 gets me 10, plus 1 gets me 11. So this is 11/5. Here I have 1 times 2, plus the 1. 1 times 2 is 2, plus 1 gets me 3. Same denominator. Okay, we multiply across the numerators, the top. 11 times 3 is 33. Then we multiply across the denominators, the bottom. 5 times 2 is 10. Now, if it didn't say to write your answer as a mixed number or a whole number, then we would be done. But this will mark it wrong. We need to convert it back to a mixed number. And if you can simplify first, go ahead. In this one, there were not any common factors to simplify with. So I'm going to do 33 divided by 10. So I'm going to see how many 10s go into 33. I know no 10s go into 3, so I'm going to do how many 10s go into 33. 3 times 10 is 30. Do subtraction. I get this as my remainder. Sometimes I would write it as a remainder. For this, I'm going to put it here, and my denominator is 10. So I'm going to type that over here. Just switch tools again. 3, and then I write this, and I go 3/10. Submit question. Nice, we got that one right. Okay, let's go on to this one. So I'm going to clear my drawings. This is the same process. So, number 5. I'm going to take 5 1/2 and multiply it by 5 1/5. So I need to convert these mixed numbers to improper fractions. So I'm going to go 5 times 2 plus 1. That gives me 11, and I still have 2 as my denominator. Here I'm going to do 5 times 5. I get 25, plus the 1 gets me 26 over 5. Now we learned a little bit about cross canceling in class. So I know 11 and 5 are both prime. 2 is prime. So my only thing I can do is see, does 26 have 2 as a factor? It does. So instead of 26, I'm going to write it as 13 times 2. And then, because 13 times 2 is 26, I can cancel this 2 and this 2. So now my numerator is 11 times 13, which you can do, if you're stuck on that, you can use a multiplication chart. Otherwise, what I do is 10 times 13, I get 130, and I add on another 13. That gets me 11 13ths. So I have 143 over 5. Now that will be marked wrong because we have to convert it to an improper, or from an improper fraction to a mixed number. So 5 can't go into 1, so I see how many 5s go into 14. That's 2. 2 times 5 gets me 10. Subtract, I get 4. Bring down the 3. How many 5s go into 43? 8. 8 times 5, 40. Subtract. My remainder is 3. But just like the last problem, I put that remainder as my numerator, and my denominator is whatever I was dividing by, my divisor. So I head on over to this box here, and I type 28, this fraction, 3 over 5, and I hit enter. Submit question. Good, we got it right. If you get it wrong, just try again. It lets you have 3 tries with each question, and then it changes the numbers. Then you can keep trying. So I didn't mean to close that. Okay, so I was trying to clear my drawings. Let's go on to number 6. it says Callie is fencing off an area for a dog walk. So this is like a dog park, an area to play in. Figure 8 is a diagram representing the fenced area. Okay, it says how many yards is the length of the shorter side? So if I go 1, 2, 3, 4. So these ones are a little less work. How many yards is the length of the longer side? I just have to count. 1, 2, 3, 4, 5, 6, 7, 8. Then it says what is the area? The formula for area, which you guys are pros at, but it's okay if you forgot it. Area is base times height for rectangles, or length times width. Either way, we have 4 times 8, and that gets us 32. And it'd be square yards because area is 2 dimensions, like they're the tiles. To check your work, you could count all these little green squares, but you will get 32, and we hit enter. Look at that, we earned another point. Okay, same type of question, we're finding the area. So I'm gonna leave this formula here. I'm gonna do this as a generic rectangle to find my area. That might make it easier. I'm gonna draw another rectangle over here. And I'm gonna split 28 into 20 and 8. And I'm going to split 18 into 10 and 8. And then I'm going to multiply 10 times 20. 1 times 2 is 2, 2 zeros. 10 times 8 is 80. 8 times 20 is 60. 8 times 8 is 64. So I'm going to add these all up to get my total area. This is called an area model or a generic rectangle. 8, actually I want to do 6 plus 6, that's easier for me. 12 plus the 8 gets me 20. 2 plus 2 is 4, plus 1 is 5. 508. And they didn't ask us to do units, but it would be like square units or 2 dimensions. Ooh, we got this one wrong. So I was maybe rushing, and part of me wants to restart making this video, but let's figure out the mistake together. Okay, so we had, oh, I copied down the question wrong. I'm so sorry. Do you guys see right here? I got 160. I was rushing and wrote it here. So this should be a 4. So I'm going to leave this mistake in here, partly because I don't want to start my video over, but also it's good to see even your math teacher makes mistakes. And when this turned red, I got kind of sad, and then I took a deep breath and I looked and fixed it. Phew, and then I got it right. All right, number 8. So I'm going to clear my drawings again. Find the perimeter. So remember, perimeter means all around something. In a lesson we did, we called it toothpicks. And then area of a rectangle of cardboard. Okay, so perimeter, we add up all the sides. So if we have a rectangle like this, 13.8 by 10, the sides across from each other have the same length. So I need to add up all 4 of those sides. And it's so important that I line up the decimals. My tens don't have decimals, so I can put them there. And I like to put a 0 as a placeholder. 8 plus 8 is 16. 1 plus 3 is 4, plus this 3 is 7. 1, 1, 1, 1 is 4. Remember to put your decimal there. So that would be my perimeter, how much the lengths are all around it. And you can hit enter as you go. Now area is length times width or base times height. A common mistake I see people do is that they multiply this by this, and that's right, but then they also multiply by this and this. That's not right. You just do the base times the height. So 13.8 times 10. And when you multiply a decimal number by 10, you just move the decimal over 1 to the right. And if you start to do it to the left and you realize it got smaller, that's how you catch your mistake. So it's 138. Okay, let's go on to the next question. So this one is a multiplying fractions question. For multiplying fractions, you don't need a common denominator. You just multiply across the numerators and across the denominators. 2 times 3 is 6. 7 times 5 is 35. Then you would check to see if they have any common factors. 6 only has these factors. So instead of listing all the ones for 35, I'm just going to say, do any of these work for 35? 1 works, but that doesn't help us. 35 is odd, so 2 doesn't go into it. 3 doesn't go into it, and 6 doesn't. So we have it in simplest form. We can just type it the way it is. Let's go on to number 10. Clear my drawings. Okay, this one is harder, and I included this one on purpose because I wanted you to see how cross-canceling can help. So instead of doing 6 times 40 right away, multiplying across the top, I would factor these some. Or what you can do is find the greatest common factor of the things across from each other. So I'm going to see if I can get a highlighter. So I'm going to see, oh, that's a great highlighter. The greatest common factor of 6 and 30. And I actually know that 6 goes into both of those, and that's the greatest common factor, but you could list those out. So if I divide this by 6 and divide this by 6, this becomes 5, and this just becomes 1. Now let me check the 40 and the 35. So I'm going to take my highlighter again so I can show you which part I'm talking about. The greatest common factor between those two numbers, you can write it out to check, but I'm going to tell you that it's 5. So what you can do is divide each of those by 5. When I divide 35 by 5, I get 7. Dividing 40 by 5, I get 8. Okay, now I can multiply across the top. My 1 times my 8, I get 8. And my 7 times my 5, I get 35, and there's my answer. If you didn't do that, you would get 6 times 40, you get 240, and then you'd have to do 35 times 30, and you would get 1,050, and you need to try to come up with the greatest common factor. Actually, what I would do first is I'd divide by 10 over 10, and I'd get 24 over 105. And then I'd realize it's not even simplified all the way, and I'd have to test some numbers, but I think I'd realize it's 3, and I'd get 8, and then it'd take me a little while to realize what 105 divided by 3 is. And you'd get the same thing, and I did it quicker because I knew those facts, so you can choose whichever way you want. Go on. Okay, we've got an LCM problem, least common multiple. So what we're going to do for this one is just list the multiples of 9 and list the multiples of 4. So when I list the multiples of 9, I go 9, 18, 27, 35, oops, sorry, 36. I got distracted, 36, and then I get 45. If I count by 4s, 24, 28, 32, 36. 36 is the smallest one they both have. One trick is to count by the bigger number and then go, does 4 go into 9? No. Does 4 go into 18? No. And so on until you get the number that works for both. Okay, this one is the greatest common factor. So for greatest common factor, you're going to list the factors of each number, and you can use a multiplication chart and think of your divisibility rules if you're stuck. 2, 4, 5. So you're finding all the numbers that go into 20 and all the numbers that go into 30. 1, 2, 3, 5, 6, and 30. And the biggest one, the greatest one they both have is 10. So that's their answer for that one. Okay, let's go on to the next question. Prime factorization. This is one a lot of people struggle with. First, on paper, draw a factor tree and figure out factors of 70, a factor pair. So 7 times 10 gets me 70. I circle the prime numbers. Prime numbers don't have any factors except the number in itself. Then I split 10 into 2 and 5, which are also prime. To type this question in, you first type the number, and it doesn't care what order. Then you hit the shift key. So I'll type the shift key, and then the number 8 types that little dot we've been using. Then I type my next number, shift and the 8 key, and so on. And that is my answer. Okay, next question. Lowest terms, that means we find the greatest common factor. So I would list out all the factors of 6 and all the factors of 30. 1, 2, 3, 6. Or I could do the factors for one of them and see, hey, does 6 go into 30? Yeah, it does. So let's use 6. I divide by a giant 1. And 6 divided by 6 is 1. 30 divided by 6 is 5. That one, my answer is 1/5. Okay, moving on to the next question. So here we have 2 fraction circles. We first write the improper fraction. That means my numerator is bigger than my denominator. So I'm going to count how many green slices or teal slices I have. I have 1, 2, oh my gosh, the pen's being weird. 1, 2, 3, 4, 5. The denominator is always the size of the slice. So the number of slices in one pie. So if you look at one of the circles, it's cut into 3 slices. So I'm going to write 3 as my denominator. So basically what I'm saying is I have 5 green slices that are size 1/3. Okay, and then it says as a mixed number, that means an integer, a regular number, and a fraction. It's mixed. So we count the number of whole pies we have. There's just one whole. This would be the one whole right here. I'm scribbling on it. The other pie has 2 colored in out of the 3 total slices. So I can type that in. And submit. And those 2 are equal. So 5/3 is just another way of writing 1 2/3. Okay, going on. This one, to write it as an improper fraction, we actually did this when we were multiplying. We have 14 times 5 plus the 4 is our numerator. 14 times 5 is 70 plus 4 gets us 74. So 74/5. And that is our answer. Number 17, write this as a mixed number. Some of you draw pictures for this. Some of you count by the denominator. I just like to write it out as long division. That's actually the quickest way for me. It saves the most time, and then I can see my steps. So I say, how many 10s go into 17? Just 1. 1 times 10. Subtract. My remainder becomes my numerator. My denominator is the number I was dividing by, my divisor. So I have 1 7/10. And my mouse is stuck. Sorry about that. I have 1 7/10. Okay, 3 more to go before I finish this video. This one you've known how to do longer, but it is a little more steps. So when you're subtracting or adding fractions, you do need a common denominator. So we need to find the LCM, the least common multiple, of 8 and 5. So we count by 8s, 8, 16, 24, 32, 40, 48, and so on. 5, 10, 15, 20. And if you realize that you don't have to list the 5s, you could just say, hey, if I look at all these 8s, the first one divisible by 5 is 40. You can use that. So I'm going to take my 7/8 and my 1/5, the fractions from the problem. I'm going to use giant ones to convert them each into an equivalent fraction that has 40 as its denominator. So my 8, to turn it into a 40, I multiply by 5. Giant ones need to have matching numerators and denominators because that's what makes them equal 1. 7 times 5 is 35. 5 times a what gets me 40? 8. Put 8 in the numerator. 1 times 8 gets me 8. So I am writing the same problem as the original. It's just I made the slices of the pie into different sizes. So I have 35 minus 8. That gets me 27 over 40. And you would need to check to see if there are any common factors between 27 and 40. I'm going to tell you already that this one does not have any common factors. Okay, 2 more questions left. Okay, this one we are adding two mixed numbers. Again, we need to have a common denominator. So we would find the least common multiple of 3 and 7. So you would list 3s and 7s. My shortcut is to count by 7s, the bigger number, and go, hey, are these divisible by 3? 7 divisible by 3? No. How about 14? No. How about 21? Yes. So, but you can list them all out if you want. The more you do these, the more you start to realize shortcuts. Okay, I'm copying down the fractions with giant ones, and I'm converting them into equivalent fractions that have 21 as their denominator. 3 times 7 gets me 21. Need to match in the numerator. 1 times 7. 7 times 3 gets me 21. These need to match. 3. And this is plus. So 7 and 3 added together get me 10. You need to check to see if 10 and 21 have any common factors. They don't. We also need to add the 6 and the 3. That gets me 9. So I have 9 and the 10 21s. Submit question. Okay, one question left. This one is area. Recall that area for rectangles is base times height. So I need to do 6 1/8 times 5 1/4. I need to convert these to improper fractions first. 6 times 8 is 48, plus 1 gets me 49/8. 5 times 4 gets me 20, plus 1 gets me 21 over 4. Now, this would be a great one to use cross-canceling, but 8 and 21 don't have any common factors, and 48 and 4 don't have any common factors. So this problem is going to be a little bit annoying. So we're going to do 49 times 21. Forty times 20 is 80, or 800, sorry. 20 times 9 is 180. 40 times 1, 1 times 9. I add all of these up. 1029 is my numerator, and my denominator is 32. Now, this is the last question, so I want it to be kind of tricky, but this is going to be a little frustrating to divide this. And for this one, I'll say you can check it with a calculator if you want. We're trying to see how many 32s go into 1029. It helps me if I count by 32s on the side. And I'm just going to do the first three. So this is 1 times 32, 2 times 32, 3 times 32, and just see. I might count more, but those were the easiest to do. So I say, how many 32s go into 10? None. How about into 102? I can tell if I add on another 32, it'll get too big. So I have 3. 3 times 32 gets me 96. And then I subtract. So I would need to borrow 10. Sorry, it's hard to write on this. 12 minus 6 is 6. Okay, so that was 6 because 9 minus 9 is 0. I bring down this 9. How many 32s? We know 3 is too many, so just 2 32s go into 69. So 2 times 32 is 64. I subtract. I get 5 as my remainder. That's my numerator. My denominator is what I was dividing by originally. Notice that this being 32 is just a coincidence. So I'm going to type 32 in 30 seconds and really hope I got this one right because it's a lot of steps. Good. I did one of these earlier and made a mistake, and that is okay. There's a lot of steps. I put this one last. If you don't get this one right, you can still get an A on this assignment. All right. Let me know if you have any questions.